Hello. Today we're going to discuss about the new concept in C program, which is the actually Unit 5 of our syllabus. That's called structures. We get the structures in C programming. That's the topic today. Structures in C programming. So first of all, what's the structure? The structure is said to be a user-defined data structure. It's actually a data type, we can say. User defined data type. So we have data types like integer, float, character, double, like that, which are called primitive data types. And we can have our own data types called user defined data types, which is nothing but a combination of basic data types. So structure is a user defined data type. So here the syntax of using structures, so is first we have to define a structure, or first we have to define a data type. So this is a keyword. Struct is a keyword, and I can show you some other one more. This also I can show you. So I can say struct is a keyword. So this is a definition of a data type, new data type. So for example, the data type char, which is a char array, integer, which is integer array, and there is a float, and all these three are combined together, and we say it's a single data type. That's called a struct geeks for geeks. That's a structure name. Or you can say some more examples like there is a structure called address. So this is a data type. Structed address is a data type. So which is having a one character array, second character array, third character array, fourth character array, and there is a integer variable. So 4 character arrays plus a integer is combined together, and we say it's a data user defined data type. Okay, so that's what the structure definition. So you see the syntax, so it ends with the semicolon. So you put all these things here, and you can just use this one. So this whole thing is called data type. It is equal to link, integer, it is equal to float or char. Even this space is also included. So struct along with this the tag, we say it's a data type. So for this one example, struct space geeks for geeks, the whole thing. So it's a keyword and a tag. These two things together, we say it's a data type. So this is a definition of data type. This definition of data type carries these three entities inside. So if I declare a variable of this data type, so it will be allotting 10 bytes for this, 5 into 4, 40, 12, 20 for this, and then 4 for this. So 10, 20, 30, 30 plus 4, 34. So if you leave out the padding, it's actually 34 bytes. So if I create a variable of type struct geeks for geeks, it will create a memory which is of size 34 bytes. Okay. So now this for the first thing is definition of a structure. So this is a definition of a structure, and here we have the definition of a structure, and here they are declaring one more structure called person. So here we say struct person. This is a data type, user defined data type. It has 3 variables inside. One is a character array, one is an integer, and one is a float. So 50 bytes for this, 4 for this, 4 for this. So 58 will be allocated for this. So this is a definition of structure. We define structure. Okay, syntax of structure definition. Next comes the creating structure variables. So for example, this is a definition. The definition ends with a semicolon. Now we have a main function, and this is a definition. Usually the definition goes outside the main function, and I have a declaration here: struct person, person1, person2, p20. So here you see this one, struct person. This is a data type. See this one, struct person, struct person. This is a data type, and I have person1, I have person2, I have p20. So variable 1, variable 2, and we have an array of person. So this one, how many variables are created? Actually 1, 2, and actually here there are 20. So 22 details, 22 person details I can store. Here person 1, person 2, here P0, P1, P2 to P19. So totally we can store 23. So 20 here, 22 here we can store. Okay, so this whole thing is a data type. So this is called a structure variable declaration. Once I declare, it will create that much memory size. If I declare person 1 will be allocated with 58, person 2 will be allocated with 58 bytes. So here 58 into 20, there are 20, each one will be given with the 58. So it's an array of structures. So P20 is nothing but an array of structures. These are various ways of creating structures, structure variables. As a structure variable. So first we are declaring how do we create a structure, then how do we declare a structure variable. So here are some examples. Struct point, it has two variables in pxy. This is also one way to create. So if I put this outside this structure definition, now p1 is a variable. Okay, now here just coming alone, and the xy are members of struct point, but we ended the semicolon. Now here inside the main I just put a variable p1. So this p1 is a local to main. So if I put this whole thing outside, this p1 is outside the main. If it is example, if this, imagine if it is not there, that means this will be outside the main. Then this p1 will be a global variable of struct point, so which can be accessed by every function in that file. So how do we initialize structure variable? This one thing you should remember: we cannot initialize. We cannot initialize inside the definition. That's what main thing you have to understand. So if I declare struct point, you cannot just put a equal to 0, and like this you cannot put. So this you should remember. So you cannot initialize it this way, and the way to initialize are: this is structure definition, and there is a main, and there is a struct point p1 here equal to 0, 1. So if I give these two values, if there are two things, the first one will be assigned to first one, second value will be assigned to second variable. So if it is y x, means 0 will go to y, 1 will go to x. Now in this case it's x and y, so 0 goes to x and 1 goes to y. The corresponding values will be initialized with. How do we access structure elements? So there is an operator called dot operator. This is very new to you. Compared to the previous C concepts, the dot comes for the first time. So this is a structure members are accessed using a dot operator. Now for example, this is struct point is having x and y, and we have declared p1 carrying 0, 1. Now this way one we can initialize. Now I am just accessing members of p1 using a dot operator. See this one, there is a dot. How this is accessing? P1 dot x equal to 20. Okay, or p1 dot y. So p1 dot y is y value is actually 1. Now p1 x is 20. So in this case x will be 20 and y is 1. So we are initializing this way. Not initializing. Initialization is 0, 1. I am accessing after that. Once you want to access after initialization, or without initialization, if you just declare, if you want to give values, you have to use a dot operator. So struct point, this is the definition of a structure. This is a declaration of a variable. This is initialization. This is after initialization. I am accessing using an operator called dot operator. So here p1 is a variable. Variable dot member. X is a member in the structure. So then I am giving a value. So if I want to print it, I want to print this value. So I am accessing x, and then I am accessing y. So x goes to this place. This p1 dot y goes to this place. Okay. What is the designated initialization? There are some other ways of initialization, like x, y, z are there. Examples of initialization using designated initialization. So here, if I give 0, 1, 2 without this designation, 0 will go to x, 1 will go to y, 2 will go to z. But if I want to change the order, for example, I want to change the order. P1 is 0, dot z is 1. So here y is given with the value 0, z is given with the value 1, x is given with the value 2. So the order you can just change it. You have to use just dot z dot members, then this one way. Now this point p2, one more declaration, point p2, which is local to main, so it's a local variable. So in this x I am just putting 20. I'm not initializing y and z for p2. So here x is got this value that I'm printing. I'm accessing all p1 members, no problem. So 2 0 1. So they are printing x, x is 2, they are printing y, y is 0, z is 1. So that is printed. Now they are just printing x because we are assigned with the x with the 20 is printed. So now in this case, if you try to print y and z for p2, it will be showing some junk values because p2 is a local variable. If you did not initialize, it will be a junk value. What is an array of structures? That's the next concept is array of structures. So here struct xy is there. There's a declaration of structure, and we have a array. See this one. So this is a data type, struct point. Struct point is a data type. So ARR is a array name and there are members 10. So this is a array of structure. This array of structures. So here the array starts from 0 to 0 and it goes up to 9. So there are 10 member array. Each member is a struct point. Each struct point member is having two integers x, y. So 8 bytes into 10, 80 bytes. Actually the array size will be allocated as per the theoretical concepts. Access array members. So 0.x equal to 10, 0.y equal to 20. So here 0th structure we are giving values 10 and 20. In this way we can access. So this is the array of structures. You can just give anything, 1 dot, 2 dot, 3 dots I can give for all the structures. What's the structure pointer? Now the structure pointer, now next concept is structure pointer. See this one, this is structure definition, no problem. The same way as in here, this is not changed, this is structure definition. Structure definition is x and y. Now struct pointer, I have declared a struct point p1, 1, 2. We are initializing p1 with the x is 1 and y is 2 inside the values. P2 is a pointer to structure p1. See, for example, they are just giving a data type star. If I give star, the p2 is going to store a address because p2 is going to act as a pointer variable. So because it's going to store address, but the address points to struct point structure. So they are just putting ampersand. Ampersand is the address of operator, or I can say it's a reference operator. So p1 is a structure which is a variable, structure variable, and I'm getting a ampersand. So p1 is having 8 bytes. So ampersand of p1 means starting address of the p1 will be stored in p2. Now p2 is pointing to p1. That's the meaning. So p2 stores address. That address is pointing to a structure. So p2 is not a structure. P2 is a pointer to a structure. P2 is just storing a address value which is pointing to a structure. So what's the size of P2? That's just 4 bytes because address size is 4 bytes. So it's just a number, integer. So P2 stores address, and that points to a P2 stores a address, that star. That address points to a struct point. So this way we are storing. Accessing structure members using structure pointers. See this one. So we are, as of now, we are used dot to access members. So if you are accessing members, the members are x and y. If you are accessing members using the variable, structure variable, then you have to use dot. But if I am using a structure pointer, so if you want to access the members using a structure pointer, you have to use an operator called this one, arrow operator. So that's what this topic is about. So like primitive, we can have a pointer to a structure. If you have a pointer to a structure, the members are accessed using arrow operator. Earlier it was dot operator, now it is just a arrow operator. So here, for example, so P2, using P2, I am going to access x and y. P2 is pointing to P1. So P2, the direction operator, the indirection operator is, we can say it's arrow. So P2 arrow, you have to just put like a one hyphen, one the greater than symbol. So P2 of x, P2 of y, you can just say P2 of x, P2 of y. So it's an arrow operator. So if you use structure to access members, you have to use arrow operator. That's what the discussion is. Then we are talking about limitations of C structure. The C structure does not allow the struct data type to be treated like a built-in data type. There is not built-in data types, but C++, Java, they have a built-in containers that actually is nothing but a modified version of structures. We cannot use operators like plus minus like we use for integer. So for example, if I have int a and b, I can just do a plus b. But if I declare two variables of structure, you cannot just do addition or subtraction. Okay. So for example, we have struct number n1, n2, n3. So you cannot do n1 plus n2. It's not a normal variable. It's actually a structure variable. So you can have many members. So you cannot do. So it gives a error if you try to perform n1 plus n2. So even though it is having only one number, you cannot just add these two inside the member. So that's one limitation, or you can say it's a kind of a disadvantage in here, but this is all rectified in C++ and Java, Python. They all support this thing. So it's a startup area where the data type, user defined data type was evolving. So at that time it was not allowed in C. Now also C is not allowing, but C++, Java, Python, everywhere that can be done. No data hiding. Data hiding is a property of object-oriented programming. So that is allowed afterwards in C++ and Java, Python. Functions inside structure. You cannot write a function inside a structure, but in C++ and Java, which is object-oriented languages, there you can write a function along with the member variables. Say for example here, so I have a name, I have a CIT number, I have a salary for struct person, but I cannot write a function inside this structure. These are all member variables, but I'm not writing a function inside this structure, so that is not allowed. But object-oriented programming will allow writing a function inside a structure kind of construct, which is nothing but a class. The concept of class is a evolved version of structure. And the static members. C structure cannot have static members inside the body. So here we have members. So this float x, this is not static. Static means it's only one copy will be created, and that concept of static is not allowed inside a structure in C. Access modifiers. C programming do not support access modifiers, so they cannot be used in C structures. This is also concept of object-oriented programming, so that's also not allowed in C. Construction, creation, structure. Structures in C cannot have constructor inside. This constructor is also a concept in object-oriented programming, so that's also not allowed. So this is startup for a class concept. So class is a main concept in object-oriented programming. Structure is a primitive or a basic version of a class, we can say. So this is what about structures introduction. So first we are dealing with what's a structure, how to create a structure or a declaration of a structure, then how to declare a structure variable that were discussed. Then how do we initialize the members of a structure, how do you access the structure element using dot operator. Then we have discussed array of structures, then we have discussed pointer to a structure. Then how do you access array structure member variables using a pointer variable. So here using arrow operator we just access, and the limitation of structures. So in the next video I'll be talking about writing programs using structures. Okay, thank you.